Hello students, welcome to Aditya Academy. I am Dr. Ragini Arora, and in this video we will be covering the rest of the questions of exercise 5.2 from NCERT. In the first video of this exercise we had covered till question 8. Now in this exercise we are starting with question number 9 of this 5.2 exercise. In this question, he says, if the third and the ninth terms of an AP are 4 and -8 respectively, which term of this AP is 0? So I hope you must have learned that same things are being asked in different manners again and again in these questions. Like if the third term and the ninth terms of the sequence are 4 and -8, that means A3 is, third term is 4 and ninth term is -8. Then which term of this AP is 0? You have to find which term, that means n you have to calculate, and the value of that nth term is given out to be 0. That means an is 0. So I hope this is clear. Third term is 4. We can write that a plus 2d is equal to 4. Then we have a9. a9 is -8. That means a plus 8d is -8. Now with these two things we have got two linear equations. I am subtracting equation 2 from equation 1. So I am changing the signs of all the terms. This becomes positive. So a minus a is 0. 2d minus 8d becomes -6d. 4 plus 8 is equal to 12. So d here comes out to be 12 divided by -6. d is -2. Right? Now we have got d. We have to look for a now. Putting this value, putting d is equal to -2 in equation 1 or 2, you can put anywhere. So a plus 2 times -2 is 4. a minus 4 is equal to 4. So a becomes 4 plus 4, that is the value of a is 8. First term is 8 and common difference is -2. We have to look for an 0. an is equal to 0. This can be replaced by a plus n minus 1d, which is 0. Question says, which term of this AP is 0? So we have to find the number of the term, that is n. And the value of nth term is 0. So a, here we have got 8. N we have to calculate. D is -2. And the value of an is 0. So we have 8. You can take 8 to right hand side. So this becomes -2 times n minus 1 is -8. So n minus 1 becomes -8 by -2, which is 4. So n minus 1 is 4. So n becomes 4 plus 1. So n is 5. That means fifth term of this sequence will be 0. So you were asked to find the number of terms. So answer is n is equal to 5. Next is the 17th term of an AP exceeds its 10th term by 7. Exceeds means it is more than 10th term by 7. The 17th term of an AP, try to make an equation as we do in linear equations. Read it in a manner so that you form an equation. The 17th term, that is A17 of an AP, exceeds means it is more. So we write more and less on the right hand side of the basic thing. More than 10th term. More than 10th term by 7. So it is more by 7 than the 10th term. Right? The 17th term of an AP, A17, exceeds its 10th term by 7. 17th term is 7 more than the 10th term. So this is how we have made an equation. Now you have to find the common difference. So by this I can write A plus 16D is equal to A10 can be replaced by A plus 9D plus 7. This is a relationship that we have got. So now I am solving this equation. So A plus 16D minus A minus 9D is equal to 7. By solving this, we get these two A's reduced. So we have 16D minus 9D is 7D, which is 7. Right? So the value of D comes out to be 7 by 7. So D is 1. This is quite easy question. Next we have, which term of the AP 3, 15, 27, 39? 3, 15, 27, 39 will be 132 more than 54th term. Right? First of all, you can write A here. And for D, you can take the difference of two consecutive terms, which is 15 minus 3, that is 12. So the value of D is 12, value of A is 3. The basic things are known to us. The relationship is asked for which term of AP, AN, which term of AP will be 132 more than 132. More exceeds, less, everything is written on the right hand side of the basic thing. 132 more than what? 132 more than 54th term, A54. So which term? That means you have to find the number of the term which is 132 more, 132 added to 54th term. So you have to look for n here. But first of all we find an. Then we will look for n for an. Right? So which term is 132 more than? An is written as an. A54 can be written as 53, A plus 53D plus 132. Right? Now this cannot be solved further. So what we have to do is, we have to put the value of an, which is A plus n minus 1D, A plus 53D plus 132. So you can solve it further. You can see that these two A's are getting reduced on both the sides. You can bring this A to the left hand side, it becomes minus A. So now we are left with n minus 1D. The value of A is given as 3. Since A is reduced, we need not put the value of A. D is 12. This is 53D, which is again 12. Right? Plus 132. Now solve this further. This is 12n minus 12. 53 times 12. 53, 2. 2 3s are 6, 106. Then we have 53. 636. 636 plus 132. So we add 132 to this. This is 8, 6, 7. 12n is equal to 768, and you can bring this 12 to right hand side. It becomes plus 12. So 12n is equal to 780. Right? So the value of n becomes 780 divided by 12. 12 6 are 72. Then we have 60. 12 5s are 60. So the value of n is 65. See, we had to find the value of n here. Right? First we had to look for the term which is 132 more than the value of 54th term. So I just wrote the value of term is 132 more than 54th term. But eventually we had to find the value of n. So I just replaced an by a plus n minus 1d. A54 can be written as a plus 53d. And then by solving the values on both the sides and putting the value of d, the value of n comes out to be 65. Right? That means 65th term will be 132 more than 54th term. Next question is, two APs have the same common difference. The difference between their 100th term is 100. What is the difference between their 1000th term? So what we do here is, two APs have same common difference. Let two APs be given as A1, A2, A3 and so on. And the second AP be given as A1 dash, A2 dash, A3 dash and so on. Now I have taken different variables to represent two different APs. Means the values of these two APs will be different. But here he is saying that the common difference of these two APs is same. That means A2 minus A1 is represented as common difference. A2 minus A1, A3 minus A2. So A2 minus A1 is D. In the same case, A2 dash minus A1 dash. This will also be represented by D, not D dash. So whatever the values of these A1, A2, A3 and A1 dash, A2 dash will be, but the difference between these two terms will be same. So I am taking the same denotation for both the common differences, since they are same for both the sequences. Two APs have the same common difference that I have mentioned. The difference between their 100th term is 100. That means if we are continuing with this sequence, the term which is appearing at 100th number will be A100. And the term which is appearing in this sequence at 100th term will be A100 dash. Right? Now he says the difference between the 100th term of these two sequences is 100. Considering this as the bigger one, I am writing A100 dash minus A100 is 100. The difference between their 100th term is 100. So I have taken this 100th term and this 100th term of both the sequences and their difference is 100. What is the difference between their 1000th term? So we have to find A1000 dash minus A1000. That we have to calculate. So I am solving this further. We have A dash 100. A dash 100 can be written as A dash plus 99D. I am simply using the formula for nth term. An dash will be A dash plus n minus 1 D dash. D dash is nothing but equal to D. In both the same APs, common difference is same. So we cannot denote 1 by D and 1 by D dash. Since they are same, I am writing D as a common thing in both the sequence. So A dash plus 99D is equal to, now this has to be written as A dash plus 99D. A dash 100 can be written as this. A100 will be An here is A plus n minus 1D. Here the basic things are A and D. Here the basic things are A dash and D. So A100 becomes A plus 99D. And the difference of these two terms is 100. Now opening this bracket, A dash plus 99D minus A minus 99D is 100. You can see that these two can be reduced. So A dash minus A is 100. What is A dash? A dash is the first term of the second sequence. What is A? A is the first term of this sequence, right? A. So that means the difference of the first terms of these two sequences is also 100. They had given us the difference between the 100th term was 100. Now we have got that. The difference between the first terms of these two sequences is also 100. Now we have to look for this. A dash 100 can be written as A dash plus 999D. 999D. Then this A1000 can be written as A plus 999D. Right, now to solve this, I open these two brackets. A dash plus 999D minus A minus 999D. You can see that this is again equal to A dash minus A. So it doesn't matter what is the number of term, if they have common difference and the difference between the first two terms is fixed, that will be the same difference between any particular number of terms. A dash minus A is equal to 100. So the difference between the 1000th terms of these two sequences will also be 100. This is your answer. Right? How many 3-digit numbers are divisible by 7? Okay, now we have first to make an AP and then answer this question. How many 3-digit numbers are divisible by 7? That means you have to form a sequence which is 3-digit numbers. Sequence starting with the 3-digit numbers. Moreover, you have to look for the multiples of 7. So we know that 3-digit numbers start with 100. But 100 is not a multiple of 7. So you have to look for the first 3-digit number which is a multiple of 7. You can see that 105. Right? 105 is divisible by 7. So 15 sevens are 105. This is a multiple of 7, and since we have to make a sequence of 7, we can keep on adding 7 to this. This is a multiple of 7, so every number which is at a distance of 7 will be a multiple of 7. Add 7 to this. Right? And this is the sequence that we have got. See, the first term is 105. This is the first 3-digit number which is a multiple of 7. 100, 101, 2, 3, 4 are not divisible by 7. By taking out the first term, we keep on adding the required number so that the sequence is all about multiples of 7. Now we have got A. A is 105. D is clearly 7 here. So what we have to find is how many 3-digit numbers are there. So we have to take down this sequence till the last 3-digit number which is a multiple of 7. Now the last 3-digit number is 999. We have to check whether this is a multiple of 7 or not. 7 ones are 7. 29. 7 fours are 28. 19. 7 twos are 14 and 5. So you can see that 999 is not divisible by 7. Now what will be the number which is divisible by 7? You can see that 5 is the remainder. You subtract 5 from 999. 994. 994 will be divisible by 7. You can check. 994 is divisible by 7. 7 ones are 7. 29. 7 fours are 28. 14. 7 twos are 14. So the last 3-digit number which is a multiple of 7 will be 994. Right? This is your AN. This is your A1 which is A. A2 and AN is this. Again, AN is given to you now. The value of AN is 994 and you have to find how many numbers are there in this sequence. So N is to be calculated in this question. So in this question you have to work out all the things first. You have to make an AP, you have to find AN, and finally you have to answer the number of terms in the sequence. So AN is A plus N minus 1D. A here is 105. n we have to calculate. D is 7. A is 105. This D is 7 and AN is 994. So 994 minus 105 is equal to n minus 1 into 7. 994 minus 105. 14 minus 5 is 9. 8. 889. 889 is equal to 7 times n minus 1. So 889 divided by 7 is n minus 1. 7 ones are 7. 18, 7 twos are 14, 49, 7 sevens are 49. So 127 plus 1 is n. N is 128. That means this sequence consists of 128 numbers. Or you can say that this is A128, which is the last term of the sequence. How many 3-digit numbers are there? So there are 128 3-digit numbers which are multiple of 7. 3-digit numbers multiple of 7. Right? Next question is, how many multiples of 4 lie between 10 and 250? Again, this is the same kind of question, but these 10 and 250, you have to check whether they are the multiples of 4 or not. How many multiples of 4 lie between? Between means when they are given the boundary elements, if it is between, that means you cannot take 10 and 250. They have to be excluded. Between means the numbers have to be other numbers excluding these two boundary elements. So we start looking for the first number, which is a multiple of 10, multiple of 4. That is 12. 12 is the first number after 10, which is a multiple of 4. And then we make a sequence by adding 4 to it, because we have to look for the multiples of 4. 16, then add 4 to it, becomes 20, then add 4 becomes 24. Now you have to look for the last number which comes immediately before 250, and it is a multiple of 4. So you can do 250 divided by 4 is 4 6 are 24. 4 2s are 8. 2 is the remainder. Subtract 2 from 250. That is 248. So 248 will be the number which is a multiple of 4, as well as it lies between the boundary elements 10 and 250. Right? So the AN here becomes 248. Again you have to, how many multiples? Again you have to calculate n, number of the terms. Like if AN represents 248, so what is the number of this term? So A here becomes 12. D is 16 minus 12. So D becomes 4. The value of AN is given to you as AN is 248. So I am just using the formula. AN is A plus N minus 1D. So I am putting it as 248 is the value of AN. A is 12. N we have to calculate, and D is 4. 248 minus 12 is equal to 4 times n minus 1. This is 8 minus 2, 236 is equal to 4 times n minus 1. 236 divided by 4 is n minus 1. 4 5s are 20, 4 9s are 36. So 59 plus 1 is equal to n. So n becomes 60. That means in this whole sequence we have 60 numbers. Or you can say A60 is 248. Right? Next question is, for what value of n are the nth terms of two APs equal? Two APs are 63, 65, 67 and so on. Second is 3, 10, 17 and so on. That means for what value of n, the nth terms of two ABs will be same. So we have to take n as common to both the terms, but A and D's are different. Like A here is 63. D is A2 minus A1, that is 65 minus 63, which is 2. Now in this case we can represent as A dash is 3, right? And A2 dash minus A1 dash is 10 minus 3, which is 7. So D dash here is 7. D is 2. So basic things we have got now, right? A and D for this, A and D for the second sequence. So he says there is some value of n for which the nth terms of these two APs will be equal. So here I am looking for an, that is A plus n minus 1D. And this an comes out to be A, which is 63. N is not known to us. D here is 2. Right? In this case, an dash is denoted by A dash plus n minus 1 D dash. A dash is 3. N we have to calculate. And D here is D dash is 7. So we have to assume that at some point these two values will come out to be same. The values of an have to be same. So for that I am equating here an is equal to an dash. That means 63 plus, I am opening this 2n minus 63 plus 2n minus 2. 63 minus 2 is 61 plus 2n. So I am simplifying this. This is 61 plus 2n. In case of an dash, it is 3. An dash is equal to 3 plus 7n. 3 plus 7n minus 7. 3 minus 7 is minus 4 plus 7n. So this is minus 4 plus 7n. So we're considering that these two values of an will be equal at some point. So equating them, what is the value of n? This is 61 plus 4 is equal to 7n minus 2n. This is 65 is equal to 5n. So we have 65 by 5 is equal to n. N is 13. That means 13th term of both the sequences will be same, right? Next we have determine the AP whose third term is 16 and seventh term exceeds fifth term by 12. Determine the AP whose third term A3 is 16 and the seventh term, that means A7, exceeds the fifth term by 12. That means seventh term is 12 more than the fifth term. Seventh term is 12 more than the fifth term. So these are the two relationships that we have got, and we have to find AP. That means A and D have to be calculated. Now we form these two equations like A plus 2D is 16. And from this we can write A7. A7 means A plus 6D. A5 can be written as A plus 4D plus 12. A7, A plus 6D, A5, A plus 4D plus 12. So this is the relationship. Now how can we solve this? A plus 6D, bring both the terms to left hand side. So this becomes 12. A minus A, 6D minus 4D is 2D, which is 12. So instead of using elimination from this only equation, we can get the value of D. This is 12 by 2, which is 6. D is 6. We can simply put this value in equation 1. Putting D in equation 1, so we have A plus 2 times 6 is 16. A is equal to 16 minus 12. So A is 4. Now we have found A and D. So the sequence becomes 4, add 6 to it, 10, add 6 to it, 16, add 6 to it. This becomes 22. The sequence is 4, 10, 16, 22, then dot dot. This is the AP. Next question is, find the 20th term from the last term of the AP. Find the 20th term from the last term of the given AP. Now AP is 3, 8, 13, and the last term is given as 253. Right? Here you have to learn a new concept, how to move backwards in a sequence. So A here is 3, right? And for D, you can use A2 minus A1, which is 8 minus 3, that is 5. L is 253, right? See, the last term can be called AN or the last term L. L is 253. Now he is asking for 20th term from the last. You have to go backwards and find which is 20th term from this number. Now what we have to learn is, you can see that if we go forward, we are adding 5 to this, right? Just try to analyze this thing. This sequence is obtained by adding 5 to the previous number. We add 5 to 3, we get 8. 5 to 8, we get 13, and so on. If we have to move backwards, we have to subtract 5 from this term and so on, right? So now I am moving backwards, considering the sequence this way, right? I can start with, you can say that AN. Your first term here becomes your 253. This way, this is last term. And since we are moving backwards, this becomes our first term. And you have to find A20 from here. So here, I'm writing L as the first term, which is 253. And D in this case becomes minus 5. Right? Because this way it is positive 5. And if we go this way, obviously it becomes negative 5. So we have to find L20. L20, that means 20th term backwards. So that will be, we subtract 19 times D, so we get 20th term from here. So just try to analyze that I am converting this into a backward sequence. This A20, instead of from the forward sequence, I am taking L20, means backward sequence. First term here becomes 253, L. And we have to find 20th term. The only thing here is D comes out to be negative. Right? Now keep on subtracting 5. So the D here is, if D 5 is positive D, here negative 5 becomes the D. Right? So I'm writing minus D here. L is 253. N is 20. So 20 minus 1 is 19. And D is plus 5. So the common difference for this backward sequence becomes negative 5. Right? So D here is, D is positive in this sense. So we are writing D minus D over here as minus 5. So this becomes 253 minus 95. 253 minus 95. 13 minus 5 is 8. 14 minus 9 is 5. this becomes 158. Right? The only thing you have to keep in your mind is your last term becomes the first term, and since you have to look for the 20th term, the pattern of AP remains same. So A plus n minus 1d. The only thing is the first term has to be replaced by last term, and the common difference, if it whatever it is in the forward direction, take opposite of that in the reverse direction. These two things have to be kept in mind. The formula remains same. So we had to find 20th term from the back. Our first term becomes the last term, and the common difference, it was positive 5 in the forward manner, so I took negative 5. We have to go backwards. So the 20th term from the back becomes 158, right? The sum of the 4th and 8th terms of an AP is 24. And the sum of the 6th term, 6th and 10th terms is 44. 4th term and 8th term. Sum of 4th term and 8th terms of an AP is 24. And the sum of the 6th and 10th terms. 6th and 10th terms is 44. These are the two equations. When we open them into their basic forms, we will get two linear equations in two variables a and d. Then we have to find the first three terms of AB. So this is very simple. I'm replacing A4 by the value of A4, which is A plus 3D. A8 is A plus 7D, which is 24. Next is, you can simplify this further. A plus A is 2A, 3D plus 7D is 10D, which is 24. We can solve it further. See, 2 is a common factor on both the sides. So I'm taking out 2 as A plus 5D. Taking this 2 to the right hand side, this is 24 divided by 2, which becomes 12. So this is the first equation. Second equation says A plus 6. Sorry, A6, which is A plus 5D. A10, which is A plus 9D. Sum of 6th and 10th terms is 44. This is A plus A, 2A. 5D plus 9D is 14D, which is 44. Again, 2 is a common factor. So I take out 2 from left hand side. It becomes A plus 7D. Divide that 2 on the right hand side, so it becomes 22. So these are the two equations. A plus 5D is 12. A plus 7D is 22. Now subtract equation 2 from equation 1. Change the signs of all the terms. 5D minus 7D is minus 2D. 12 minus 22 is minus 10. So D here becomes minus 10 by minus 2. D is 5. Right? First variable we have got. Now putting D in equation 1. It becomes A plus 5 times 5, which is 12. So A plus 25, which is 12. So A becomes 12 minus 25. A is minus 13. Right? Now we have got the first term and the common difference. So we can make any AP. Like first term is minus 13. Add D to it. Plus 5. So it becomes minus 8. Add D to this. Minus 8 plus 5 becomes minus 3. Add 5, which is minus 3 plus 5 is 2. So the AP is this is minus 13, minus 8, minus 3, and so on. We had to find first three terms of the AP, which are minus 13, minus 8, and minus 3. Right. Next question is, Subbarao started work in 1995 at an annual salary of 5,000 and received an increment of rupees 200 each year. In which year did his income reach rupees 7,000? So you have to find an AP with this word problem. So Gaurav started work in 1995 and the annual salary of 5,000. So the first term here in the sequence is 5,000. And he receives an fixed annual income every year. That means the common difference here is same, so we can call it an AP. He is receiving a fixed amount as an increment for each year. Here that is rupees 200, right? In which year did his income reach 7,000? So that means we have to find n after how many years, or in which year he will be receiving rupees 7,000 as his salary, right? So A here is 5,000, D is 200, AN is 7,000. This is an AP because the common difference for every year is fixed. It is not based on the basic income. If the basic income is fixed and we have a particular part of that income to be increased, this would not have been an AP. Since the change in the value for every year is constant here, so this is an AP. AN is 7,000. A plus N minus 1D is 7,000. The first value is rupees 5,000. N we have to calculate for how many years he has worked to reach the salary of 7,000. Annual increment being rupees 200, right? So here N minus 1 multiplied by 200 is 7,000 minus 5,000. 200 N minus 1 is 2,000. So N minus 1 becomes 2,000 by 200, that is 10. N is equal to 10 plus 1. N is 11, right? That means after 11 years, he will get a salary of 7,000. So in which year did his income reach 7,000? So you have to add 11 to the existing year. He started in 1995. So after 11 years means in 2006. In 2006 he will be getting, in year 2006 he will be getting a salary of rupees 7,000, right? Now the last question of this exercise is, Ramkali saved rupees 5 in the first week of a year and then increased her weekly savings by rupees 1.75. If in the nth week her weekly savings becomes 20.75, find n. Now again you can see that she is starting, the first term of this sequence is rupees 5. She is starting with the savings of rupees 5 per year, right? And then she is increasing that amount by a fixed value, which is 1.75 per week. Since this change is fixed for all the weeks, that means this is an AP. And so the D here becomes rupees 1.75. If in the nth week her weekly savings becomes 20.75, that means at a particular time the value of her weekly savings is rupees 20.75. So we have to find after how many weeks she reached to this point. What is the number of week in which she is saving rupees 20.75, right? So A here is 5, AN is 20.75. Value of AN is A plus N minus 1D, which is 20.75. First value here is rupees 5. She had started with rupees 5 as a weekly savings. N we have to find. And the common increase every week is 1.75. Common difference is 1.75. Now we solve this. This is n minus 1 into 1.75. This is 20.75. Take this 5 to right hand side. So it's minus 5. 1.75 times n minus 1 is 15.75. So this is n minus 1 here becomes 15.75 divided by 1.75. To simplify this, if you are afraid of decimals, you can see that there are 2 digits after decimal in both numerator and denominator. So we can remove decimals like 1575 divided by 175. So what is the value now? Divide both numbers by 25. 25 sevens are 175. 25 6s are 150. 75 25 3s are. So this is 7 9s are. So we can say that n minus 1 is 9. So value of n is 9 plus 1. N is 10. That means we have to find n. That means after 10 weeks, she will be saving rupees 20.75 weekly. So the value of n is 10 here. Right. So I hope these questions were clear to you and you liked watching this video. I would like to request you to just subscribe, like and share it with your friends. Thank you.